So as I mentioned, serverless is probably my favorite topic in the cloud because if you like to build technology, this is probably one of the best tools that you can use. And so I'm going to talk about three different aspects of serverless. First, I'm going to talk about the cloud service model, and then I'm going to talk about functions and why they apply to serverless. And then I'm also going to talk a little bit about the ecosystem, and then I'm going to get into some hands-on examples. So to really explain serverless at the beginning, we need to talk about the service model itself. And to do that, I can actually just draw this maybe at the bottom here to make it a little bit simpler. So you have, when you're building things in the cloud, a spectrum. You have infrastructure as a service, which is the lowest level. You have the platform as a service, which is a little bit higher level. And then you have things like serverless. And the big distinction here between these different models is that infrastructure as code means that really you are getting the low level pieces. So you could be getting the CPU, the storage, maybe also the network, and you're controlling explicitly each of those components. And this would be a lot like in the real world going to a big store that has the raw ingredients like, flour, sugar, meat, things like that, or vegetables. You're basically getting the core ingredients, but then you have to cook the food yourself. And so that's really the way to think about infrastructure as a service. So on one hand, if you own a restaurant, you could make a lot of money because you could buy the food for cheap and then sell it for more money. It's the same way with the cloud. If you buy things cheap using infrastructure as a service, you can construct things and then sell that to other companies. And that's actually done through something called SaaS or software as a service. So it's a lot like the same example of a restaurant owner. Now, platform as a service is a little bit different, and we can draw an arrow here, because platform as a service is something where it's a lot more like a restaurant where you could actually order the food. So you could go through and you just order what it is you want. And it's almost like going to somewhere where you can tell the person making the food, what it is you want in your burrito, right? So if you've ever gone to a restaurant where they let you decide what to put in the burrito, you can say, I want chicken and I want some rice, right? So you didn't have to buy the chicken, you didn't have to buy the rice, but you still have control over what it is you want to build in there. And so what are the options in the cloud that are similar? A lot of these are web service based components. So the technical analogy here would be a Google App Engine, or GAE would be a good example of a PaaS. Also a Elastic Beanstalk, so we'll call this EB on AWS, would be a good example. So these are services where you still have to do a little bit of work, but most of the servers themselves are actually handled by the cloud vendor. So I find myself leaning towards a lot of times wanting to use something like this because I don't want to go down to the low level a lot of times because it's a lot of work, and that's not really what I'm trying to solve. I'm trying to solve for a problem. Now, serverless would be even easier and more of a high level. And so the analogy here would be just like you order something in person and you can customize things, serverless is even easier. It would be like ordering takeout food. So it would be like if you went to a restaurant on the phone and you call them up, or you go on a website and you say, look, give me the food, bring it to my house. There's nothing to do. You ask for it and they give it to you. And what's nice about serverless, and we'll get into this, is that it's really the lowest level of abstraction in terms of automation. Or I guess you could say, depending on how you define it, it's either lower or the highest level of abstraction. And that basically what this means is that you can think in logic, and the logic will directly correspond to what it is you're trying to build. And so what are some examples of this? the examples of this would be functions. And so these would be things like Google Cloud Functions, AWS Lambda, and I'll get into this in a second and explain why this is so important. So really that's the main thing to think about when you talk about serverless. It's that you're moving away from doing everything yourself, and there's, depending on how you define it, you could still define serverless as platform as a service because you're not managing servers, but in generally it's moving away from doing things yourself. Instead of spinning up virtual machines, attaching storage, doing network connections to things, you're using high-level services that automate a lot of it. And so if you're a builder and you want to focus on building technology, then this is probably the kind of technology that you want to focus on. And as I mentioned, the cloud providers themselves, this is really where they're focusing most of their energy, is on this the platform as service and serverless. So let me talk a little bit about the functions next here. Before I get into the ecosystem. So one of the things that is interesting about serverless is that it capitalizes on this concept of a function. And so if I go here and I say serverless and functions, I think I've mentioned this before that with AWS, they're probably the leader in serverless, and they have something called AWS Lambda. And well, what is AWS Lambda at its core? Really, you could think of it as something called FaaS, or function as a service. And so what this means is that at the core of anything that you build that's serverless is the Python function. And it could be really as simple as, for example, I could do this. I could say def, and I could say, hello, and then I take some payload, we'll just say it's X, and then I return back, let's say X plus 1. That really is potentially all you would need to do to build out some kind of resource, right? It's just a couple lines of code. And if I put that into AWS Lambda, I can then make it go all over the AWS ecosystem. I can attach triggers to it. I can build web services. So really the heart of serverless is just a function. It's really something that is a couple lines of code, and it can accept an input, it can process it, and it can return it back out. And so that's a really key thing to understand about building serverless technology. Now, the concept of a function, though, is a very interesting concept, because outside of just building things in the cloud, this concept of a function also can be applied to other computer science techniques. So in particular, let's say that you want to do GPU programming, and I'm going to show you an example of this in a second. Well, you can do the same thing. You can just have a function, and you can attach, let's say, a decorator on top that says essentially use a GPU, and then now you can dispatch this function and run it, let's say 10 million times very quickly across a GPU cluster. And it's just that function. And all you did was put a decorator on top. You also can build command line tools by just attaching a decorator on top of something and building something. You can also build a web service. So you could build a Flask app, and it could, again, be just a function. The other things you can do with a function, you can also do data science. So if you go to Pandas, for example, Pandas, most operations that are helpful require you to build an apply function. So you would do .apply here, and then the function would go across every row and actually do those operations. So this is really at the heart of actually thinking about serverless, is that when you really get down to it, in terms of cloud computing, it's a distributed system, and it works really well with this concept of I have a small piece of code, and then I use that small piece of code to do something. It could be a cloud function. It could be a GPU operation that has incredible scale, like 10 million rows that I process all concurrently. It could be command line tool, web app, data science application. It could be, machine learning. You could do an ML problem with it, and sometimes it's just a few lines of code. And I think this is really the key reason why serverless is such a fun technology, is once you understand that the power of things is to encapsulate it in a very small amount of code and then connect those pieces together. So that's serverless, and kind of setting the stage for some other stuff I'm going to talk about. The other one I wanted to bring up before I get into some code examples is to talk about the ecosystem. So the serverless ecosystem itself has a lot of traction, and in particular, probably the leader right now is AWS. And so let's just talk a little bit about, let's say with AWS, what are the things you can build with serverless technology? So we know that there's AWS Lambda, which is a great way to build services. There's also step functions. And what step functions do is they will connect different Lambda functions together. So basically, you can take one Lambda function, hook it up so that the output goes to another Lambda function, and you can encapsulate this in something called a step function. And so you can chain together many different operations. So that's a little bit of the lay of the land with AWS. Now, the other thing you can do with a Lambda, we'll just call this L, is you also have this thing called triggers. And this is probably the biggest shift that you'll see in building these things, is that you can hook up a Lambda function to, let's say, 25 plus things in AWS. So what can you do? Well, you could trigger a web service. You could also trigger an operation where if you put a file in S3, you could call your Lambda function. You could also process data, right? So you could take a stream of data and you could trigger it with Lambda. There's a whole list of things that you can do. You can do timers. That's another one you can do, is you can actually tell something to run at a certain interval. So in terms of AWS, that's really the lay of the land, is AWS Lambda, step functions, and triggers. That's the majority of what's happening on that ecosystem. So I guess I could call this AWS ecosystem. There's another library, though, that's called Chalice, that I think I'll have time to talk about, that might be worth looking at as well, that can also do some of these things. It's still AWS Lambda, but the people that wrote the Bodo API, or the main SDK for AWS, also wrote something called Chalice, and it makes it easy to do some of these things I just discussed. So that's the AWS ecosystem. Now let's talk a little bit about the GCP ecosystem. In terms of the GCP ecosystem, they have some interesting technologies, and we'll be able to get to, I think, a lot of them today. So GCP ecosystem, there is something called Cloud Run, which is one technology that, in fact, there's a whole book on it right now called Cloud Run. And what this is it's basically a Docker container that you can turn into a full-fledged service. So you can basically go and build a container and just put it through, we'll say Cloud Run, and then make it turn into, let's say, an API. So that means that you could take any Docker container, check it into their container registry, and then make it into a service. And so what this does is allows you to have a lot of control over what you build, because you can explicitly put inside the Docker file what packages you want to be installed, what do you want it to do, all kinds of different things. And in general, the Cloud Run ecosystem is a really powerful developing ecosystem. Now, the other thing that they have, so you could call this maybe container as a service, CAAS, but basically you just take a container and it deploys it. They also, though, have cloud functions as well. And so that does similar things to AWS, where you can just put a piece of Python code somewhere, and then that piece of Python code can get a trigger, and the trigger could be a web service. It could be maybe like a message that comes in via a pub sub. So in general, they're really in parity. And then also with the Azure ecosystem, if I just talk about that real quick, they're doing similar things. With Azure, they're really in parity as well. So Azure has cloud functions as well, so you can build functions. And they also have something called app services, which is a platform as a service. And this would take the like a Flask app, for example, and you could take that Flask app and you could deploy it without having to manage servers at all. And so I actually have an example of that I can just talk about really quickly here that shows how app services would work. So if I go to here, Flask ML, Azure serverless, this is a great example of why you would potentially want to use something like Flask in a serverless environment, is that I can hook this up to GitHub. I can have it listen to events using their build system, which is Azure Pipelines. And then I could have a platform as a service offering called Azure App Services, just kind of sit there and listen for when changes happen, and then it can automatically deploy my changes. And so what's great about this is I don't ever have to manage servers, spin up virtual machines, set up networking. It's all managed at a high level by this ecosystem. And again, the same thing exists on the Google platform. They call it Google App Engine. And then on the AWS platform, they have a parity service called Elastic Beanstalk. But the concept is the same, is that either this platform as a service or the functions really is where I think a lot of traction is headed. And so if you wanted to run this yourself, you could just you run this project, and I have steps that you can go through where I step by step show you, create a project. You then go through and you say AZ web app up, and then it spins up the app service. After the app service is spun up initially, you'll see that it'll host up a website. And then from here, you could go through and set up the DevOps project inside of their pipeline, so it'll automatically deploy. Once you do an automatic deployment, then if we scroll down here, you could build out a config file that has the information that you would need to build the job. And then finally, the final step would be that after you ran through it, you could actually maybe add additional testing or linting so that you have a higher quality of your project. So yeah, again, you could go through here and run this yourself. This would be a good example project, and I can put this into a message here. But so if I go through and go back now to the Sketchpad, I guess the core concept here is that in all cloud platforms, you're going to have functions and you're going to have these services, and they're somewhat related to each other. This is more of completely hands off, and this is slightly more. You have to do a little bit more, but in general, the idea is that it's a service that you don't manage the servers yourself. So I think that's really is probably a good spot to dive into a couple different examples here. And I'm going to show this notebook here and just kind of talk about this concept again of function as a service. So if you think of function as a service, it really is the center of the universe, right? With cloud computing. And I basically talked about some of this a little bit ago, but with just one function, you can build web apps, command line tools, do parallel computing, decorators, pandas operation, do lambdas, Google Cloud Functions, do GPU programming. And in fact, what I wanted to show you was an example here of doing some GPU programming, and we can kind of show how, again, a function is doing all the work here. So I'm going to use a Colab notebook, and this Colab notebook, I don't think I need to install anything, but if you need to export that to Jupyter, you could do that. I'm going to select runtime here, and I'm going to change the runtime, and I'm going to make sure that it says GPU. And so the GPU will allow us to use an NVIDIA-based GPU here, and actually use it to do parallel programming using the GPU. And so what I'll first do is I'll build a function that is a Mandelbrot function. And this will just use regular Python to do this operation. You can see here, it's really not a ton of stuff going on. It accepts some things, it generates some numbers. And then to create a fractal, I have one more function called create fractal. And then it will go through and run this Mandelbrot here, right? You can see that that's where it calls it, and then it generates the images, and then I can actually go through here and now finally generate the Mandelbrot. I think I need to import NumPy here, so I need to run this. Okay, there we go. So I import some libraries. I import NumPy. I import this library called Numba, which I'm going to use later. But if I go through here again, just run through these, what we'll see is that it will take a long time to run this code, about 5 seconds or 4.7 seconds here, and it generates this non-deterministic visualization. It's pretty slow because it's in pure Python, and Python is not a very high performance language. But we can still think about things in a function, and we can use a function to do more powerful things. So how would we do this? Well, there's a library in Python called Numba. And what Numba does is it allows me to use something called the LLVM just-in-time compiler. And so this Numba will allow you to translate a subset of Python and NumPy code into machine code. So basically assembly level code here. And you can see some examples of what it does. And what's neat about this, again, is it's a function. And then this is all a decorator is a function that wraps another function. So again, we see that all of the power in Python is with a function. And it's either a function that has another function that wraps it, or just a normal function. So you can do things like use the just-in-time compiler, or you also, if you wanted to, you could do more complex things. You could do threading. So Python has a global interpreter lock where it can't do true threading. It can't use, let's say you bought an AMD Threadripper machine, which I don't know if you've seen these, but you can buy for home now. You can even buy, I think, machines that have over 100 cores available for your home. They're expensive, but if you ran Python, you would only run on one core, and so you'd be wasting all those cores unless you did something like this and you said parallel true, again, just a function, because it's a decorator that wraps another function, and you could run true threaded code down at the C level, and this would actually use all of the CPU cores. As well, you can use the GPU acceleration here. If we went to, we wanted to use NVIDIA, which we're going to do in a second, CUDA, which is their SDK, or you could also use the AMD as well, if you have access to an AMD driver. So that's kind of the lay of the land. So now let's go ahead and use this. We'll say @JIT. So we'll use the assembly translation, and we'll run the same code. So we'll go through here, and then we'll run the Mandelbrot, and notice that it's instantly 10 times faster because the function would translate the code to assembly, and now it's fast, which is great, right? It runs 10 times faster, and maybe that's something that you could use in the future. But one of the things that's interesting is that we could go even faster by using an even more advanced technique and use the GPU itself. And so to do that, what we can do is use something called CUDA JIT. And what this does is it'll take the code and actually throw it at the GPU, in this case, the NVIDIA GPU. And so because this is a highly parallel problem, we can actually accelerate the speed even faster. And so if I go through here and I run this, you can see that, in fact, now it's even 100 times faster than the original one, or roughly 100 times faster, because it used the GPU. So I think one takeaway here, and there's some other stuff you can go through on your own, but the main takeaway here is that really most of the exciting things that you can do in the Python language, it really involves functions. And so that's a good way to think, is like I have a function that has another function on top, or I have a function that goes into the cloud somewhere. So again, that was the GPUs, but let me also show you an example. As I mentioned before, there's a framework called Chalice. And what's interesting about Chalice is that if you wanted to do this on your local machine, let's say you wanted to run this on your desktop or something, you can run this framework called Chalice, and you could say, look, I want to build a new web application. And what's neat about it is that all you need to do is say, basically pip install Chalice, and then it'll run a tool called Chalice new project, and it will give you, again, a function. And you just put a decorator on top, which is a function that wraps another function, and then you put your code in. And what it will do is it'll create a web service. And then if you later wanted to deploy it, all you need to do is say Chalice deploy, and then it would deploy it into the AWS ecosystem. So if you have some time, we won't go into this one today, but this would be a fun one to play around with, that also highlights how quickly you can build a fully working web application that's available to the public by just using this Chalice framework. The other thing you can do as well with Chalice is, here's an example, is that I can say I want to schedule a task to run, let's say, every 5 minutes. So what I could do is I could say, again, add a decorator. The decorator will wrap this function, and it could do whatever I want. In this case, it doesn't do anything useful. It just says hello. But what if it was scraping a website, or what if it was grabbing some information from an API or monitoring something? Whatever it is you want to do, you can do just by putting this decorator on top. You can tell it to run a task for you. And again, this would run in the AWS ecosystem. You also could really easily write something that could talk to the S3 bucket in AWS. So we know that AWS itself has cloud storage where I can put objects inside of S3. Let's say every time I put a movie file or an image or some kind of document in a bucket, and I wanted to not spend a lot of time, but I wanted to write some code that processed that data every single time it happened. Well, you can do this in just a few lines of code, because it's, again, a decorator and it has a function. And then that does all the work. So I think this is really like a big inspirational moment, is that almost anything useful in Python, in the cloud, and with anything fun that's happening is a decorator, probably combined with some other decorator somewhere. And that's how you can do a lot of powerful things. Now, the other one that I won't have time to get into too much, but I'll just at least mention it, is with serverless, is that there is something called serverless, which is an open source framework. And if you want to play around with this is all another way of doing similar things to, let's say, what I showed you with Chalice. In addition to AWS, though, there's also Google Cloud Functions. And so what are some of the things you can do with Google Cloud Functions? Well, these are very similar to what you would do with AWS, but you can do ETL. So this is probably one of the common ways. And in fact, I've talked to a lot of people that are replacing the big data operations they're doing with Spark or Hadoop. And they just like, I don't even need to do this. I just need to write a function that gets called based on some kind of an event. And then they're transcoding video, they're transforming data, they're calling services. So that's one strong use case for the Google Cloud Functions. Webhooks as well, so responding to messages from a chat system like WeChat or Slack or whatever, and then doing something like making a bot. Also APIs, if you want to quickly build an API, that's a great use case for these. Mobile, so if you wanted to listen to an event, you have a mobile app that you want to push an event to it, and then it runs something on as a result of that. IoT, which is a really big field right now, so temperature sensors, solar energy, all kinds of things here that you could do with IoT, that every time the IoT device does something, it could trigger this cloud function that maybe processes that data. So really, it's a pretty simple process to build a cloud function with Google. Here is you go through, you say, I want to build a cloud functions, and you can actually edit it right in line, or you could upload a zip file and then you put inside the requirements, and then you go through and you build out your function here. So that's actually one of the things I'm going to build right now. So I'm going to go to GCP Cloud Functions and just show you how simple it is to build a cloud function. So if we go through here, I can just type in functions, cloud functions. And to build a new cloud function, you can say create function. And again, we know it's just a few lines of code and we can do tons of things. So let's just call this maybe hello, just a hello 1024, like this. And then I can decide at this point what kind of trigger I want to set up. And this is really the key way to control cloud functions on any platform, is that they're event-based. And so what it means is that they only will fire based on some kind of a trigger. And in this case, the main trigger probably for many people would be the HTTP or like a web service. But you also could respond to messages. You could also respond to storage. You could also use these high-level services like Google has their own cloud databases and analytics systems. You could also respond to one of these things as well. So from here, I'll just keep it with HTTP, and then you decide, whether you want to have something that requires authentication, or you want to use unauthenticated invocations. I'm going to go ahead and say unauthenticated invocations, and then if I wanted to as well, I could set up additional configuration information. So I could go through here and say, how much memory do I want to have allocated to this? When do I want this to time out in seconds? And I think it says here the default is 60 seconds, so we wouldn't necessarily have to put this. And then as well, this would be, you can set an upper bound. So let's say that you really didn't want this to be called that often. You could say that maybe only you wanted it to be called, let's say five concurrent instances could run. And so this looks like it's good. We can go ahead and go to next here. And then from here, I would just pick the runtime. And there's a lot of different runtimes. There's Python 3.8, 3.7, Node, Java, Go. So I'll go ahead and say Python 3.8 here. And then it will give us a main file here, which is all the Python code. And then it'll also give me a requirements file. And the requirements file would be where I would put in whatever packages I wanted to install. So maybe to start with, I'll just do like a hello world here. And you can see that I'll just take this documentation out because it's annoying. It's too much. It makes it hard to read. Okay, so if I go through here, what I can do is I can say, basically, if I pass in something that has a message in the JSON payload, then it will return back the what was inside the message, basically. And so otherwise, it'll just return back hello world. So I can go ahead and deploy this. I think that should work. Let's go ahead and deploy this, and then we can just test it out. And I think the deploy typically is pretty quick. It doesn't take too long to deploy. And if you select this, once it's in maybe 30 seconds or so, that if you go to testing, this is where we could go through and set up the trigger, right? So all the trigger would be we would pass in the JSON payload to call it. And we know that it said, I believe, message. What it's looking for, and I could just say, this is a cool function, or something like this, and I could just kind of wait on this. Wait on this, and then when it's deployed, I can test this thing out. So give it just a second here. I'll just copy this in case. Oh, there we go. So it's already ready to go. So if I just say test the function, hopefully that works. If I scroll down to the bottom here, it's looking at the logs. And let's see, hopefully it's been successful. I think the first time you use it in a while, it has to wake up to make sure that, I think they typically, if you haven't used a particular service for a while, it's a little bit slower than usual. Okay, so we got something going. And what does it do here? Looks like it returned with a status 200. That's a good sign. And it should give us the output is, this is a cool function. Because, yeah, I think it basically does nothing, right? Like it just returns back what it is we told it to do. So if I wanted to change it, I could tweak this a little bit here, and I could say, for example, if message and request args, I could basically say return if request JSON and message. I could say, let's just edit this. So I'm going to go through here and I'm going to edit this function and make it a little bit different. So let's go to the code here. What is this? Go to next. Here we go. So I'm gonna go through here and say, you know, payload is equal to, and we'll make an F string, and we'll say this was, I'll say payload returned, or something where it shows that I was processing it, and then I can put in this request.json here. We could try this. It's possible I screwed up, but this looks like it could in theory work. And then I can actually say return payload. Right, so basically it'll just return back the initial payload here, and I'll just put this message at the beginning so that I know that I processed it. All right, we'll go back here, and I think this deploy will be a lot quicker now because it's already been deployed. There we go, and we can see that it's version 2. And that's actually another neat thing about these cloud-based functions, is that you can go back and go in time and look at the different versions and actually test the different versions of them. And so if this deploys successfully, then I should be able to say message again here. And then we'll say, this is a new payload, something like that. Let's see if this thing is able to process. So a little bit slower than, it's definitely a different process than the way AWS Lambda works, where it's almost instantaneous the way you deploy it. So let's go ahead and test this. We'll go ahead and test this function. If I scroll down here, yeah, I don't see those messages. Maybe I need to print them out for it to appear. But anyway, the core idea is that it looks like it ran. But what I'm going to do now is actually move on to a slightly more complex function here. And in this case, what I'll do is I'll use this Wikipedia function, which is a little bit more complex in that it will use a library now, like a third-party library, and it will grab a web page, and then I'll be able to actually build off of a more complex example. So what I'm going to do here is go back to this, and I'm going to build a new function. We'll create a function here, and we'll call this Wikipedia 1024, and I'll keep everything the same here, and then just say unauthorized here, and go to next. And then I'll go through here and I'll say Python 3.8. So here, if you want to build something that's slightly more complex, this is where I would put in the package. And this is actually an enhancement over Python in AWS for their lambda, which is a little more irritating. All I need to do is just say whatever library. It could be pandas, Wikipedia, scikit-learn, whatever it is you want to put in here. And then for the main, this is where I'll swap this out, is that I'm going to take this code, which I think should just work if I just paste it in here, and I'll show you that I will need to change the entry point if I change the name of the function, right? So notice in this case that the function name is called Hello Wikipedia, so I'll need to say the same thing. I'll need to say Hello Wikipedia, like that, so that it's got the same name as the function. And I think this is there so that you could build a more complex cloud function if you wanted to have a lot of functions that were above that, for example. It's then up to you. So what this one will do, if the code works the way I hope it works, is that this will get the JSON request, and then it will look for the word entity, and if it's available, it should print out this this Wikipedia code. Now, hopefully that this we'll see if my code works the first time. It's possible it doesn't. I have another example I could show you if this one for some reason doesn't work. I've probably already built this, and I could run that example, but hopefully this works on the first time I deploy it. So we'll go through here and we'll test this out. So I guess the big takeaways with the cloud functions on Google is that one of the advantages that they do have is that they make the Python packages really easy, and they make the testing process pretty easy. It's a little bit annoying that it takes a long time to deploy changes, but I think there are some things that they do that are pretty neat. And in fact, I'll show you another capability they have, which is that you can also test your function by calling it from a command line in the Google Cloud Shell, which is pretty neat capability. So from here, hopefully, again, my code works. No promises, but maybe it works. We'll say Google. So see if it'll grab Google's web page here. Does it blow up? And so we had some kind of an error. So I've already built this earlier, so I'll just go to one that I know works. Let's see here. How about Wikipedia demo? Does this one work? Let's look at the source code and see if I changed it. No, that one doesn't look like it works. I think I have one that's, let's try this one. Maybe I have an example here where I must have somehow put some bad code in here. But I have a slightly more complex one that I'll show you, which uses the same code, but it's even more complex. So this, I believe, was, yeah, this is basically a more complex version of that code. So notice here that I have a requirements file where I put Wikipedia, and then I also have Google Translate. And what I do is that I import the first library, Wikipedia, and then I import something called Google Cloud Translate. And what this does is it allows me to use the cloud translation technology to translate the Wikipedia page. And so this is a pretty good example of the stuff that would be useful to do if you were going to build a cloud function, because this could just be some tool you build for yourself. Maybe you don't even share it with other people. And I built a function first called translate text, And this will just take in some text. And you can see I make an instance of the Google API. And then whatever text comes in, I translate it to whatever language is passed in, right? Which is this language here. And then, and I print it out right here. So I just print this out. The next thing that I do is that I notice that the entry point for this is called translate test. So I will then take the request and I'll get the JSON payload. And then I'll look for the word entity. And then I'll also look for the word language. And then I'll print out the results of the translation for that particular language. What I can do now is to run this, which I think it is running. I can just say testing. And then I can say the entity would be Google. Go through here and go to Google. And then I believe that the language would be, I think we can say Spanish is probably a good one. And then if we test this, hopefully everything works successfully. It looks like, I don't know why this one has got a problem other than maybe what I can see here is it in theory it should look something like this, but let me show you from the command line because I know that works. You can also invoke this thing from the command line, which I think is probably one of the coolest parts of this whole service. And so I'm going to open up the Cloud Shell and then I'll figure out, I'm probably messing up the payload or I'm messing up something. And so this also shows you that, how it's actually really easy to integrate both command line invocations of the function and then also the web-based invocations of the function. So just give me 1 second and I'll be able to debug this. So if I go to history, this is a great way to debug things, is I believe I can even look for, I think it's called GS, let's see, what is the name of this cloud function tool here, which is called, gcloud functions. So basically this is what I want to find, is I want to find this, gcloud functions. And I can say grep this word. Gcloud. So here we go. So this is I think a different function that I built earlier, but you can see that here I say gcloud functions, translate, so call the cloud function that I built. I think this is a different named one, like maybe an older one that I should delete. And I pass in the data, and the data is going to be the entity Google. I also put another parameter here called sentences, and then I also say which language. So if I run this, in theory here, this should work. Let's go through here. Well, that's irritating. There we go. So let's run this one right here. Let's run this. Let's see if this works. There we go. So let's go ahead and authenticate. So go ahead and authenticate. Okay, sure. Maybe I'm in the wrong. Okay, copy this. Yeah, no, I think this is the right one. Not sure why it's taking so long to to hang here, but well, regardless, not sure if I screwed up my account or whatever. In theory, this is what it should look like when you call it, is that you will, basically build out these small functions and that's very confusing to me that this one for some reason has got problems, because I've never had problems with it before. But the core idea is that you can not only invoke it from the command line, but you can also invoke it from the web, and so it gives you a lot of capabilities in terms of invoking it. And so similarly, we can move on to the AWS cloud. You can do the same things with AWS. So let's kind of move to another cloud here, and I think we'll have a lot better luck. For some reason, Google Cloud is acting strange tonight, but with AWS console, it's kind of the same thing, right? I can go to lambda, and I can build this function, and inside of lambda, same thing. I would just say create a function, and I can say from scratch, choose a runtime, and they're very similar in that you can notice that I would create a function name, and this would be the container for this. So we can call this one, hello AWS. And in terms of the permissions, one of the things that's a little bit different about the AWS serverless ecosystem is that with AWS Lambda, if you want to call another part of the AWS environment, you would need to actually change the execution rule so that you used a rule that would allow you to call an API. So if you're just playing around and you're just doing basic data operations, you don't need to control this. But this is something that is really critical, that's easy to make a mistake on, is that your execution rule could have a problem. So in this example, though, I'm just going to do something really basic to just kind of get the wheels turning here. And what we can do is very similar to the Google Cloud, is I can just put some stuff inside of here and say, if event has the word name in it, for example, if name is equal to John, prints, hi John, else print, hi not John, something like this. So really simple functions here. I think what I like a little bit better about the AWS environment is the feedback loop is a lot quicker, where it took a long time to deploy with GCP. And so to test this, first I would just need to save it. So go here to save it, create a test event. And to create test events, what I would do is I would say, test hello, and then put in the word. So we'll say name is equal to John, right? And we can format it to make sure it's correct. And this, in theory, should say should work as long as I did. Yeah, one thing that is different here is that, let's go ahead and test this. There we go. We can see it says hi John, right? Is that it looks like they changed this with Lambda, where they copy the same thing that you do with GCP. Is in order to run it, you have to click deploy, which is a pretty new functionality. If I wanted to test the other condition, I could create another one here, and I could say, not John, like this, and then say Bob or something like this, and it would go through and run it. The other thing that you can do here with there we go, hi not John, right? So I mean, you saw how I don't know, there's something going on with the GCP cloud. it seems a little bit more finicky, like it's really easy to break something that's very subtle, where the AWS Lambda functions seem to be a lot simpler, where there's less things that go wrong. The other thing that you can do, as I mentioned, and the core capability of Lambda that gives it all the power is the trigger. And right here, if we go through here, you can see that they're constantly expanding the kind of things you can do with AWS Lambda. So in particular, if I wanted to build a web service, I could select this API gateway. If I wanted to build a IoT interface, if I wanted to talk to voice control, I could talk to this, which is pretty interesting. Also, I could do, there's something called CloudWatch events. And what this does is it goes through and allows me to run a trigger at a certain interval. And that's a pretty useful one to be aware of. And then also the streaming. So you could accept streaming data. You could accept S3 data. And then another one that's pretty interesting that's not talked about a lot is that you can actually accept SNS topics. And what's interesting about SNS topics is that it's a great way to build highly parallel systems. And let me just sketch that out real quick and say why this is so important. So with the regular version of Python, for example, one of the things that's we talked about is that there's a level of global interpreter lock, right? So Python, when it is run outside of the cloud, has pretty big performance problems because of the GIL, or the global interpreter lock. But because of the cloud, one of the things that you can do is, in particular with, let's say, AWS, you can actually run a Lambda SNS hook that calls a Lambda function, or an SNS to Lambda. So if I said SNS to AWS Lambda, I could, let's say, write a command line tool, and the command line tool could send, let's say, 1,000 messages that are very simple messages. The messages could be a payload that says maybe they're websites that I wanted to process. And each one of these would contain a request, a payload that would just be like the name and then some website. And then what would happen is I don't have to worry about the fact that Python is slow anymore, because SNS could, in parallel, it could invoke 1,000 lambdas at the same time. And those lambda functions could do the work, right? They could go through and like scrape a website, or they could process information. And all I need to do is send an SNS topic message and then attach that lambda function to it. So that's one of the things that's really neat about using the cloud to build concurrent operations, is that I can actually build highly parallel systems that you can think of SNS plus Lambda almost like true threads in C++, where I could, as many messages as I send to SNS, Lambda will invoke in concurrent all those and process those payloads. So I think this is one of maybe the least talked about ways to do highly concurrent operations, and why serverless can really be super powerful by using the right types of triggers. And if you want to look into that, you can see, let me just show a little bit more here, that in order to do this, if we go to, let me just go to SNS real quick. I'll show you how you would set that up. If you went to SNS, you could, it's basically pub sub. You could create a topic here, and the topic could be, let's see here, standard, and just say like, highly concurrent or something like this. And then we create the topic, and then all we need to do for subscriptions is we could create a subscription here to highly concurrent, and then the protocol could be AWS Lambda, just like that. And then from here, the Lambda function could be the one I just created, which was whatever I called that thing. it doesn't really matter because I'm not going to use it. But basically, you could just pick some Lambda function, and then every message you send, which could be really, really simple message, would just fire off that Lambda function. So I think, again, as I mentioned, this is a great way to build massively parallel systems by just a little bit of code. This would just be a very small amount of code, and this SNS Lambda would trigger it. So let me show you, now that I've, that one blew up a little bit, but in theory, this should work. I don't know why mine's not working. But if I scroll down here and I look at AWS, which I think I have an example here. I think we've already gone through some of this before, but this Lambda handlers, if you wanted to build an API, that's the other one that would be kind of a neat one to build, is that if I wanted to build a full web service and then deploy it via API gateway, that would be kind of a fun one to build. It show how I could build a publicly facing web service. So let's go ahead and do that. So I'm gonna do that one next. So I'm gonna go to this and just copy this code here, and let's see if we can get this to work. Whoa, let me scroll this. The scrolling is killing me here. Okay, there we go. So I'm going to grab this, and I'm going to go back to my Lambda, and if I go into, I think we could set up Cloud9 here. It might be a good one to do. And if I just open up one I've already got running, just to make things easy, we can probably get this running pretty quickly. So the thing that Cloud9 is developing is essentially a better tool. Like we noticed we had some problems with the Google Web Services interface. This one, in theory, is a little bit cleaner to build web services in terms of serverless functions, in that they give you a wizard that will set up some of the hooks that will tie the trigger automatically for you and let you test it out in a serverless environment. So what I'm going to do is I'm going to click on this button here, and I can probably even delete a bunch of these. Let's just delete these. Let's just say delete, and then maybe delete all this stuff as well. We don't need any of this. Okay, so I'm gonna now go to AWS Resources, and I'm gonna build a new Lambda and go through this wizard. And I'll call this change 1024. And then it'll prompt me for the stuff that's important. So Python runtime. This is a little bit annoying that they give you an older Python runtime. It looks like they're still working out some of the updates. But this is the key part to build a web service, is that you would say the trigger API gateway, and this would allow it to turn into a full-fledged web service. And if I'm successful, no promises, we could actually deploy this into production. So if I go through here and I say change, that would be the URL I would want this to deploy at. I also could say I don't want any security for now, and then I'll go through here and say next. I don't need a role as well because I'm not doing anything. I'm just running a very simple request, and then I can say finish, and then it'll give me this basic structure here that has everything I need. So in theory, I can just paste what I had earlier, and what it will do is that it will, let's just make sure that the code, unused variable response, oh, well, there we go. Well, that would be a problem. There we go. Return response. That's helpful that I found that. Let's see what else does it find. Invalid syntax, line 24. Status code 200. Maybe return response. Status code 200 headers. I'm not sure what What is wrong here? Res depend. So maybe because I cut and pasted it, I'm gonna go to another spot where I have the same code. Maybe this something, I've got a cut and paste error. So I'm gonna go to another repo I've got that should have a better version of this. So we'll go to AWS Lambda, and let's take this one here, and let's grab this one. So I think this is the one we want. I must have somehow put a spot in there or something, but let's run this thing. Let's go here. Create the wizard. Where's my change function? Doesn't look like it's here. Doesn't look like it's here. Oh, there we go. Here's the one I want. So this one. So grab this. All right. So I'm going to paste this into this environment, and hopefully that fixes the bug. I don't know what I had in there, but it must have been like a weird. Sometimes you get invisible characters. So that looks good. And then I can actually right click on this and then say run local. So first I want to see if it does anything. And I think it's looking for amount. Okay, so it looks for amount. And I can go through here and say amount and do 134. So does this work? That's helpful. We got something working today. And then you also can change this to act like it's a web service by going to API Gateway Local. And then I would want to change to a post operation, which means that I can accept, that means I would accept a payload from a web request. So if I go through here, I can say amount and then do this. And then hopefully this one works. And go through here. Are we 2 for 2? There we go, 2 for 2. So we got two web services. So in theory, that's one of the really cool things about the Lambda ecosystem with Cloud9 is that I could build very, very quickly a full-fledged web service, and then I can actually deploy it. So to deploy it, I would just right-click here, and I would just say deploy. And then this would actually put this into their ecosystem, and then to call it, all I would need to do is to do a post operation to this service. So let's go back to Lambda, and let's see if we can get this thing working here. Or there we go, Lambda, and I believe that we can, looks like it deployed. Hopefully it lets us see the code. Okay, looks like it's good. So notice that it has this. So I'm gonna go ahead and test it here. So I'll do the same thing I did before, which is, we'll just say change, and I'll just do amount, and then do 134. This should work, but this doesn't necessarily test. So it worked. Or let's just double check here. So it worked, right? But I want to test the web service. So how do I do this? There's a couple ways to do this. One, if I click on API Gateway, it should show me the actual URL right here. And here should be the endpoint, is that shows me the URL to use, and then here's actually the what I would call it. And I believe I can go to this thing, and if I can effectively put in a payload, I haven't done this before, but I believe I can say, I can either do, there's a way to do this. If I can't figure it out in a second, I can also do it a different way. But basically you should be able to, yeah, for some reason, there's a way to actually enter you can actually inside of there enter manually the payload. But the easier way to do this would be I could just go to here and I could copy this link address and I could test this from my this environment. So there's a library in Python that does, I could either use a curl command or I could use a library in Python to do this. And I guess I could be lazy and do the request library. So if we look at requests in Python and do a post operation. So first I'm going to paste this in here so I have it. So that's the URL I want to call. And then I'm going to look at how to do a request post operation, which would be this. So notice how that's how you would do a post operation. So you would say, so if we go back here, sorry, this one, I'll say source, so I'll cd into this so I can use this virtual environment. So I'll say source venv bin activate, and then I can say pip install IPython. So this will let me do an interactive interpreter. And then I'll also install pip install requests. There we go. And then I can type in IPython. So this gives me a interactive shell, and I can say import requests. And then I can say URL is equal to, whoops, I don't want that. I pasted in the wrong thing. I want to paste in this thing, which is I had earlier. I want to paste in this. I want to take that URL, and I'm going to say URL is equal to, and I'll make that a string. And then I think all I need to do is say results is equal to request.post, right, which is send this payload to them, pass it to that URL, and then for the data, we already know what the data is. The data would just be the it would be the key value pair, and then it would be the end here. So we know the data was going to be amounts and then 34. So let's go ahead and do that. We'll say amounts or whatever change I wanted to make, then 134. Just like that. There we go. And does this work? So it does look .json. So for some reason, I'm not getting a result back from this web service, but without digging too much into the code, it should look something like this, where you could actually just write some Python code and then call that production web service. Because that was so easy, though, another thing we could do to actually make this a little bit cleaner would be that we could always build maybe like a second function or do some other service that doesn't accept a post payload. But in a nutshell, I think the main takeaway here is that it's pretty straightforward to build really quickly a web-based serverless service by using the Cloud9 environments with AWS. So maybe I can cover one more thing here, which is that I wanted to cover in terms of AWS, besides the web services, this thing called step functions. And so as I mentioned before, the real advantage of something like a step function is that you can actually chain multiple things together here. And in particular, a good example would be this, where I could build just something really simple that says who, and then I would return back hello from a state machine, right? So I can kind of chain these things together, but they work best when you actually trigger these could be lambda functions that take one lambda does something, it processes it, and then it sends it to another. And then what's great about it is that I've actually got a history of everything that I've called. So it gives me, and this is a whole video on it, But basically, I think I can just take this and let's see if we can get this working. Let me look at this gist here. So I'm going to go to raw. I'm going to try to build one of these. I've been definitely picking high complexity things to build in a live training. So we'll see how this works out. If I go to step functions, it will say basically, what do you want to do? And I'll just say create a new state machine. And then from here, you can just immediately start building the logic, right, of how you want to build something out. And I guess from here, what I can do is just throw this in. And I don't even know if these functions exist anymore. I might have even deleted these functions. So what I can do is actually try to build a couple really quick that will. You can notice basically you call a task, it calls the function, and then after it returns the result, it passes the results into the next line here, and then that thing has to actually accept something. So hopefully when I was building this out, I put some documentation to myself about how I did this, which let me see how I did this before. So that would have been helpful if I would have put what I was putting into these functions, but I could just try it out and see if we can get this thing to work. So I would just need to build a couple of functions really quick, and then I would actually refer to them. So you notice if you go through here and you go to resource, it'll actually go back to whatever lambdas are available. And in fact, it'll just let you kind of scroll through here, and you can find any lambda that you built. So I can just try it. I don't have a lot of time, but I'll just try real quick. So if I go back to here, I could try to build a couple functions. We'll just go to lambda and build this, and build we'll call this Marco 1024, and then I'll say Python 3.8. And just leave everything default. And I think I just need to I think I just need to return something. And I believe it needs to return back JSON, if I remember correctly, to do something successful. So I could just leave this. I think I could just leave this in here and just say dumps body. And we can just say like Marco. And then I could just deploy this, and then I could go back to the step function and then look at this. Hopefully it will show up now. And we'll see if Marco 1, 2, 3, 4 shows up. Marco. You may have to refresh. Yeah, it may take two. This may be too ambitious to try with only a few minutes left here, but the key idea. Let's just do a hello world. That'll be an easier one. Is that if I just pick like let's see here, what a job puller. This would be a good example. That this is much more good example of some of the stuff that you can build with a step function. Is that you decide the states of what you want to happen, and then at each component you go through here and you put in the lambda function that you built. So you would have to accept a payload, process it. And so I've actually done something similar when I was working at a company that did job processing, and we built this in step function. So in a nutshell, this is just yet another tool that you have. So maybe what I'll do here since I went through so much stuff, is just summarize really quickly some of the high level tools and what they do and how you could potentially use these. So I would say that the main takeaways here, let me just tee this up. Here we go. Okay, so the main takeaways here are that AWS is probably the least complex to deal with in terms of the smoothest place to build things. There's less that can go wrong. So maybe this is a good place to start if you want to experiment with serverless, and probably the two places to start as well would be just the console. That's not a bad place to play around with building lambdas. There's a lot less that can go wrong. And then the second would be the Cloud9 environment, and you can see that it's pretty simple to, although I had a couple issues, in the real world, you're going to have issues. It's hard to always get it right in a demo, but it does make it fairly straightforward to build like an API that's completely serverless. In theory, you could build out a company using all these APIs in a few days if you knew what you're doing and everything worked by just using AWS Cloud9 and Lambda plus the API gateway. So that's one definite takeaway. And then the other one to mention is that there are other pathways in AWS, and so these can be complex, but they also can be very powerful. So we know SNS can do massive concurrency. You can also respond to any event with a trigger. And then the step functions are ways to chain together lambdas to build, much more complex systems. And then similarly with GCP, again, I don't know why that had problems today, but GCP are pretty reasonable as well, and you can do lots of powerful things with them. The one thing that I've found a little bit with GCP is it's a little bit more, we'll call it fragile, where just kind of weird things, it's probably something I did, but things can break a little bit, more easily. So I would say GCP Cloud Functions are a little bit more beta, although there's a lot of fun things you can do with them. And then likewise, other than these two, the other ones to look at are the paths, right, are similar to these, and that would be things like Google App Engine is kind of similar, or the Beanstalk, Elastic Beanstalk, or the other one that we talked about is Cloud Run. So there's a lot of emerging technology here. Some of it's in various states, and it can be complex to deal with. But on the flip side, the power, I have no doubt that this ecosystem is going to be really, really rapidly developed and get more and more capabilities. And so you could make the argument that why do anything else but use these smaller tools that let you build things really quickly.